All right, let's talk about one of those classic tech interview questions. You know the one. It sounds so simple, but it's designed to trip you up and really test your whole SQL skill set. Today, we're going to do a deep dive on how to find and delete duplicate records. We'll cover everything from the basics all the way to some pro-level performance hacks that work across all the major databases.
So here's the game plan. We'll kick things off with that classic interview question. Then we'll tackle two big scenarios, partial duplicates and totally identical rows. After that, it's all about speed with the performance playbook. We'll check out some database-specific tricks and then tie it all together with the key takeaways you need to know. Okay, picture this. You're in an interview, the pressure's on, and they hit you with this question. On the surface, it looks like a softball, but it's actually a masterclass in testing the real depth of your SQL knowledge. Let's dig into why.
How do you delete duplicate records using SQL? I mean, it seems straightforward, right? But here's the thing. A good answer isn't just one line of code. A great answer shows you understand that the word duplicate can mean a few different things. And the best way to handle it? Well, that totally depends on your data and the database you're working with.
All right, let's jump into our first scenario. And honestly, this is the one you're going to see most often in the wild. We're talking about partial duplicates. This is where every row has its own unique ID, like a primary key, but the important stuff in the other columns is just a copy-paste job. Okay, take a look at this cars table. This lays out the problem perfectly. See how we've got 2 entries for the Hyundai Ioniq 5 and 2 for the Tesla Model S? Now look closer. The ID for each of these rows is unique. We've got 1, 3, 5, and 6. But the combination of model and brand, that's identical. Those are the duplicates we need to hunt down. So how do we fix this? The go-to solution, the one that's both super elegant and works just about everywhere, is this awesome 1-2 punch, a common table expression, or CTE, combined with a window function called row_number. So what in the world is a CTE? The easiest way to think about it is like a temporary table, kind of like a sticky note for your query. It only exists for that one single command. Why is that so great? Because it lets you break down really complex problems into simple, readable steps. And for what we're doing, that is exactly what we need. The whole process is basically a simple 3-step recipe. Step 1, we partition the data. That's just a fancy way of saying we group it by the columns that are duplicated. So for us, that's model and brand. Step 2, we use row numbering to slap a unique number on each row inside those groups. And step 3, we just delete any row where that number is bigger than 1. Boom, done. And here is that exact logic in action. That partition by clause, that's the secret sauce right there. It tells the database to create a little group for the Teslas and another little group for the Hyundais. Then row number comes in and labels them 1 and 2 inside their own groups. So the final delete command is super simple. Just get rid of anything with the number 2. It's clean, it's efficient, and it just works. Okay, but now for the really tricky one. What happens if you don't have a unique ID? I mean, what if the entire row, every single column, is a perfect 100% duplicate of another one? Yeah, this is a way bigger problem. Our whole CTE and row number trick worked because we had that unique ID to tell the rows apart. We could say, keep the first one, delete the second one. But without that ID, we have no way to tell the database which one to keep and which one to toss. As far as it's concerned, they're the exact same thing. So we've got 2 main ways to tackle this. The first approach is to use a hidden system-specific trick if your database has one. Some databases, like PostgreSQL with its CTI'd or Oracle and SQLite with row'd, have this secret internal address for every single row. If you can use that, great. The second option is the universal method, the one that works everywhere. You temporarily create your own unique ID column, use it to find and delete the dupes, and then just drop that column when you're finished. Okay, so cleaning up a handful of duplicates, no big deal. But what if you're dealing with a table that has millions of rows or even billions? A standard delete statement isn't just going to be slow. It's going to be painfully slow. It could lock up your whole table for ages. This is where you separate a good answer from a truly great one, talking about performance. The huge difference here is understanding DML versus DDL. Think of delete, a DML command, like a surgeon. It goes in and removes rows 1 by 1 by 1, and it logs every single operation. It's precise, but it's slow. Now, DDL commands, like truncate or a CTAS operation,
That's the demolition crew. They don't mess with individual rows. They just wipe out entire pages of data at once. It's way, way faster because it's minimally logged. This quote from the experts at Oracle says it all. Turn the DML into DDL. The whole strategy for massive tables is to stop thinking about deleting rows and start thinking about replacing the whole table. The playbook is simple. You create a new, clean table with only the unique rows you want to keep. Then you just wipe the old table and swap in the new one. And the numbers here are just wow. They totally back this up. Check out this test from Oracle. Deleting 90,000 rows with a standard delete command took 11 seconds. Not bad, right? But the CTS approach did it in 1.5 seconds. And truncating a partition? A mind-blowing half a second. I mean, we are talking about a completely different league of performance here. It's not even close. All right, now if you really want to blow them away in an interview, this is where you do it. You show them you know the unique, highly optimized tools that different databases have built in for this exact problem. See, every major database has its own special move. MySQL, for example, has this really clever delete with a self-join trick. Oracle can do this thing called a filtered table move, which is super fast and can even be done while the table's still online. We already talked about how PostgreSQL and SQL can use their internal row IDs to be super precise. And then you've got the cloud data warehouses like Snowflake, which can do an atomic swap, basically replacing the entire table in an instant. It's incredibly fast and super safe. Okay, we've covered a ton of ground. So how do you pull all this together into that perfect, complete interview answer? Well, you need a mental checklist, a framework for picking the right tool for the job. And this matrix is basically your cheat sheet. It's your decision-making framework. You just ask yourself a few questions. Got partial duplicates on a pretty small table? Go with the CTE and row numbering. It's classic for a reason. Are the rows totally identical with no unique key? The temporary identity column is your safe, universal bet. Are you dealing with a huge data set? You've got to think DDL. Go for that CTAS approach. And of course, the golden rule. If your database has a special native function for this, use it. And that brings us to the final and maybe the most important question of all. Look, deleting duplicates is great, but it's basically just cleaning up a mess after it's already happened. The real pro move, the real goal is data integrity. So the ultimate question to leave your interviewer with isn't just how do I delete them? It's how do I build my database with things like unique constraints so this mess never even happens in the first place?